This is the front of a HP16500B Logic Analyzer, and we're going to use this today on an 8031 microcontroller to try to reverse engineer the code. And this has 100 megahertz state, 500 megahertz timing card in it, in slot C. So we'll go take a look at the back of this to see what that looks like. This is the back of the Logic Analyzer. So we have cards in slots A, B, and C. So in our C slot, we have an HP16550A, 100 megahertz state, 500 megahertz timing analyzer. And in card B, we have an HP16522A, 200 M vector pattern generator. And in card A, we have the same thing. It's an HP16522A, 200 M vector pattern generator. So there's a power cord that goes into it and a switch. We want to make sure that switch is on. Now this one has a hard drive in it. That's, I believe, is behind this panel. The other one, we looked at the 16500A, which has a floppy drive in this area, but this one has a hard drive, so it starts up much faster. So this is the top of the Logic Analyzer where I have my 8031 microcontroller that I'm going to analyze today, and pod 1 is connected to the address bus and pod 2 is connected to the data bus. So we're going to run a little program on this microcontroller and try to read it in the Logic Analyzer to see if it matches the code listing. So we can see the sequence of the instructions as the program runs, which is a good way to troubleshoot if you have an issue with the software or hardware of your microcontroller or microprocessor. It's a good way to try to troubleshoot it. It's usually the last resort, though. You don't want to use a Logic Analyzer if you don't have to, because it is a pain to hook up all these wires. But it is kind of like the last resort if you ever have to troubleshoot the design of a computer. So now I'm going to start up the HP16500B Logic Analyzer so you could see its startup sequence. So I'm going to push the power button, and it starts making a lot of noise. You can hear the fans running. So it looks like everything passed. I don't have a disk in the flexible disk, so that gave me an indication of no disk. So this is from 1992, and it's booting up. There it goes. So I wanted to show you how I'm going to talk to this 8031, and it has a monitor program that gives me some basic commands that I could use to look at the memory inside the microcontroller. So if I type an N here, it'll respond with the menu. So this what the little program does that we're going to run, it starts at location 800 hexadecimal, is that it clears out the scratch pad RAM. So if we look at the scratch pad RAM, I'm going to look at that now by typing a D command. You could see in here, well, right now there's a lot of zeros in there, but there is some data in there. Some things aren't zero. So what I'm going to do is, like if you look at this line down here, it's not zero. So what I'm going to do, I'm going to run this little program, and I run it by typing the J command, and that ran the program. It runs very quickly. So now if I look at this area, it's from location 30 to 7F. It's all zero now. So this is where the registers are located, and there's bit logic, But usually from location 30 to 7F, that's usually good for scratch pad RAM. So just wanted to show you the setup there. So now I'm going to show you how to set up the Logic Analyzer. So first thing you want to do, you could see it, we have the 200, I guess they're 200 megavectors per second pattern generators. There's an expander and the pattern generator, and this in slot C here is our Logic Analyzer. So right now I'm not using the pattern generators. I guess I should use the test boards. So we're just going to be using this card C. So I have pod 1 and pod 2. There's 6 pods all together, and they each could handle 16 bits. So I'm using pod 1 for the 16-bit address bus, and pod 2 for the 8-bit data bus. So the first thing to do is to hit this system button, system switch. So we're going to be using this is the analyzer we're going to be using. So it brings you up to the configuration, and what's neat is you can see these arrows here. So the arrows, when they're going up and down, it means there's activity. So I'll just type a command in, and you can see some of these arrows change. So you could see a little bit of change there, meaning that you want to see arrows on all your lines. That means that it's connected. If your system was powered off, say, all those arrows would go away. So that's a good troubleshooting tool. So we have this J clock connected, and that's connected to the, it's called PSCN in the 8031, and that's the program strobe enable. So whenever you read the program memory, it puts out a signal so it knows what to latch on. You need to have one clock. So we're going to do the state analysis. So we want to change this to state and move forward from there. So the first thing we want to do is in this where it says configuration, we want to go to format. So you can see there's a bunch of information here. So this would be right now, it's set up for this, for the number 1 pod. The asterisks mean you want to look at the data, and the points mean you don't care, you want to ignore the data. But we'll update this label. This is our data bus. So we're going to put, we're going to hit modify label, and we're just going to put, it's our address bus, so we're going to put AB for address bus, and then we're going to turn this second label and keep that one off. It's a little tricky to push these buttons. I don't want label. I want label 2. There it goes. So we want to turn this on, and we want to modify it to be DB, which is data bus. DB. So what we want to do is get the last 8 bits that we're connected to. So we're going to skip the first 8 bits. So 1, 2, 3, 4, 5, 6, 7, 8, and we want to put 8 asterisks in. 1, 2, 3, 4, 5, 6, 7, 8. Done. So that means we want pod 1 to be assigned to the address bus, and pod 2 to be assigned to the 8-bit data bus. So one of the other things I have to do, I'm not too sure, this might be set up for 3.2 volt logic, where this 8031 is running at 5 volts. So I wanted, rather than use TTL, I just want to have a user-defined voltage. So I'm going to set that to 4 volts, setting the thresholds to 4 volts. So that should be good enough to get over the threshold when using a 5 volt system. So the next thing I want to do is just run it, just let it free run to see if I'm getting any data. So I'm just going to hit run here. And yeah, you can see there's some data there. And what it is that there's a polling program as part of the monitor program, and it's in this area, the 0795 memory area. So this is the address bus, and this is the data bus, the 8-bit data bus. So it runs a loop over and over again. It's looking for a character, so when I type a character in, it runs a program or does something. So, but I want to trigger off a particular area where my program is located at, which is located at 800 hex. So in order to do that, I have to set up a trigger. So what I want to do is go to the trigger page here, and one thing I want to do is I want to add the time. So I hit this for count. You have a choice of states or time. So it's always good to have the time. Take a look at that. So that has a column of time. And I want to set this to 800. This button's kind of small, so don't want that one. That's the one I wanted. Might be good to have like one of those a pen or something smaller than your finger to push these buttons. So I want to set this to 0800. So the neat thing about this, I don't really have to touch the screen. You just go right above it. So anyway, I set it to trigger at 800. So my program that I want to investigate is at location 800. Okay, from here I just want to go back to the format page, and everything looks good there. So I have this master clock, which is the J clock. So I'm looking at the up edge on that, and I only have one in this system, but you can put logic in if you have multiple clocks or multiplex system. So anyway, I'm going to go run this now. So it's waiting for my program to run. So by typing the J command in here, let me do that. Okay, it looks like it ran there, so that was pretty good. So what I'm going to do, I'm going to take some pictures of this so we can compare it against the code. So I'm going to do that right now. I'll take a few photos of that. So we'll take, so I was able to capture the data, and we will take a look at it and compare it against the code listing. And so a couple other things that you could do in this Logic Analyzer is you can look at it in terms of a waveform. So we'll take a look at that. So let's say you want to look at the address bus. So you have to click on this, and we want to just delete what's in there, the default stuff that's in there, and we just want to add the address bus. And we're going to hit done here. So you could see the address bus. Maybe we'll squeeze it down a little bit, and we could do that. And then so we want to try to get some of the markers on here. So we'll do yeah, just a pattern marker. Yeah, you can have different markers and move them around. So the red line is where it started, and you could see this is address 800 here. So sometimes it'll come up with the data also, but you could see like the 8, like that's the 1, that's 8. If you go up here, and that's 801. Sometimes, let's see, if I change something a little bit here, maybe I believe it was this one here. Yeah, I'm not going to play around with that. You could go in and with the markers. Let's see. If I go back, yeah, so we could put maybe time here. Okay, so if we change that to time, you could actually get the data coming up here. X is where I believe the marker is. Let's see. Let's get back to that marker there. Marker time. Okay. Let's see. If we go back to pattern, we can move the marker around. So that's 800. You can see like this is 801 and 802, 803, 804. So that's kind of interesting to look at. And we can also look at the data bus. So we'll try that. And so we'll go delete all, continue, we'll look at the data bus. So this gives you what's in the data bus. So you can kind of compress that down and see what's in the data bus. So that's kind of neat to look at these timing diagrams. Is another way of looking at it, but I normally like just looking at the listing where I could see the data and compare it. So the other interesting thing, each time frame is 544 nanoseconds. I know it's close to 1 megahertz processor. It's a little bit less because it has 11.059 megahertz clock in it. So anyway, we'll go compare this to the listing and take a look at that and see if it makes sense. Anyway, we're going to compare the code listing against what we got from the Logic Analyzer to see if it makes sense. So our first instruction here at address 800 is 7930. So we could see it over here at 800. We got the 7930. And our next instruction is at 802, address 802, we got a 7400. So there's our 7400 there. So that's a good match. So our next instruction is at 805, address 805. So at 805, we get a B9. We actually got a double B9. We got a B9, 7F02, B9, 7F02. So this instruction here, compare, jump if not equal, is that's a 3-byte 2-cycle instruction. So it has to make, so it is the 2 cycles. 2 cycles is 2 of these periods would be 1 cycle. So in order to make up the cycle, it looks like it had a double. It doubled this one, but it seems to be right. I think that's the way that processor works. So so the next instruction is at 808. So if we go to 808, we see okay, well anyway, with this logic here, it's not going to be it's not going to be equal. So it's compare, jump if not equal. So if it's not equal, it's actually going to jump to label 2, which is 80A. So this 808, I believe, is just kind of like a prefetch. So, but it has the right beginning is there, which is 80, but then it does jump to 80A. So it's 80A. So 80A is instruction has a data of 9 in it. So yeah, you can see what's going to happen here. On the first go around, it's going to jump to label 2, so it's going to skip this one and jump to that label, and then it's going to go to 80B, which is 80 F7. So so from F7 it goes to you see it hits OD, but it's supposed to jump to back to 804. So let's take a look at that one. I have it on the next picture here. If I can get it to come up. So we'll look at that. Let's see, we got that. Okay. What I gotta do is hit that, and we're going to get the next picture. Okay, so you can see the 80D here, which has the O2, but then yes, it jumps to 804, which is F7. So to get the timing, the number of cycles right, sometimes it has to double up on the address and data. So this is the address bus here, the data bus, and this is the time for each pulse of that J clock. So two of these is considered a cycle. So sometimes it has to double up to make up for the difference, and sometimes you see the prefetch. So this kind of shows you the inner workings of that processor. So this is important sometimes if you have to troubleshoot a computer. Kind of your last resort is to get out the logic analyzer and go through kind of the hardware and architecture of that processor to see if it makes sense. So that may help you to troubleshoot the issue. Anyway, thanks for watching this, and this is the HP16500B Logic Analyzer example. Bye now.